Good morning, everyone. How are you guys doing? Okay, can I ask everyone a favor? Can I ask people kind of like file in and, fill in some of the empty seats, Let's get a group hug feeling to this. Yeah, just come on in, come on in. All right, I have 2 takers from my team. Everyone who does that will get free hugs from the men in blue. Okay, I just enjoy doing talks on the final day of a Microsoft conference in the morning. You know why? You see, all the parties are on the night before. So what we do is we take people out, large amounts of alcohol are consumed, people somehow find their way back to their hotel, and somehow early in the morning, we expect them to understand some nitty-gritty API or some intricate technical details. Only Microsoft would do that. How many of you empathize with what I just said? Okay, I see a bunch of hands going up. Okay, before I start, I need a suggestion from everyone. Okay, I need a name of some activity that all of you guys like to do when you kick back and relax on a weekend. Have beer, watch a football game. Give me a suggestion. I heard movie. Come on, give me a suggestion. Online racing. Xbox. Okay, that's good. Xbox. What about beer and football? Yeah, okay. All right. So the goal of this talk is to show you how Windows Azure is going to make you spend more time drinking beer and playing Xbox. Okay. If you listen to this talk, and at the end of 60 minutes and you're a Windows Azure user, and you're not drinking more beer, and you're not spending more time on the Xbox, I have failed. Windows Azure, more beer. That should be our new tagline, right there. Okay. I look at the word automate in the dictionary, and it has this funny phrase about how machines will replace work done by human beings. And really, if you think about it, we all like to code. We like to develop features. That's the fun stuff. That's where we really add value. But apart from that, we have to spend a lot of time in stuff which is really not that much fun. In doing upgrades, in doing monitoring, in debugging things, in diagnosis, and that's really not as much fun as watching your Xbox, right? So what I want to talk about over the next hour or so is how Windows Azure wants to make you spend more time writing code, doing the fun stuff, and leaving these other activities like upgrades and figuring out how to scale up your service to machines and to code. So that's the goal. I like to usually come up with a story or a theme for my talk. I'm a huge science fiction fan. How many of you here have seen 2001: A Space Odyssey? All right, a bunch of people. Okay? For everyone else in the crowd, don't worry. I'm going to spoil it for you just a little bit. Okay? But it's not like a Sixth Sense kind of thing, so don't worry about it. Now, when I was a kid, 2001: A Space Odyssey was my favorite movie and book. Okay? And there's a scene very, very early on in the movie. It's a pivotal scene, and the folks who have seen the movie will recognize this. And what it shows is humanity, or very early man, is learning how to use a tool for the very first time. So what happens is there's early man in very early stages of evolution, and he's been using his body for hunting and all that, and he finally figures out how to use a bone as a tool, and he tosses it up in the air, and the scene cuts to the bone tossing up in the air to a spaceship. And as a kid, I was like enthralled by this scene. I was really captivated. Because it really captured how something simple, like just figuring out how to use a new tool, led to some great advances and just some cool new technology over a long period of time. So if you remember nothing else from this talk, I want you to remember this, that we in Windows Azure, we are trying to provide you the tools. And we hope that using these tools, you can go build some of these cool things, and to give you the ability to go build cooler things than which weren't possible before. Okay, enough spiel. My talk is split into 3 parts. The first part is much longer than the others. And the first part starts off in October last year. How many of you were here for last PDC? OK, so you saw Rayosi go out on stage, and you saw Windows Azure being announced for the very first time. Now, when we announced Windows Azure, we obviously needed a way for people to go create accounts, create services, create storage accounts, manage your service, do all that. So we built a website. We call it the Windows Azure Developer Portal. And anybody who has used Windows Azure has seen and used this. Here's a screenshot of it in action. This is the familiar cube interface where you get to manage your service, you get to create stuff, you get to upload stuff, and so on. Now, we love the developer portal. And just recently, we just shipped out new bits. And you will see a ton of new features coming into the developer portal. So we absolutely love it. But there is one thing that you can't do with the developer portal. And that is to write code against it. And I'm super happy to announce that we are plugging that hole. And we are doing that using the Windows Azure Service Management API. So whereas in the past, you had just the developer portal to go manage your storage, your hosted services, see what's running in the cloud, you now have the API to do the exact same thing. And this API provides almost all important functionality that the developer portal provides. What does it mean? Now, before I dig into the details and show you code and XML and all that, I want to take a step back. I want to talk for a second about the road that led up to here and how we kind of came here in the first place. We started building this API several months ago. And right off the bat, we knew we needed a few things. We absolutely needed a way to support all common operations that you guys do. Creating services, managing deployments, changing configuration. We absolutely knew that we needed to support that. So that was given. But we also wanted to kind of figure out what were other goals and principles, and how, what religion should the API have? OK, this blurry screenshot is an email that we composed in the team around 5-6 months ago. It's blurred out because there's some content on here which I can't show you, but this is actually real. We used this email to kind of help us prioritize what our principles and goals should be when we built out the API, even before we started writing a line of code. And what I've done here is kind of taken out some of the sections and bolded them. So you can see how our thinking was even from the beginning. Right off the bat, we knew that we needed something which was simple. I remember this meeting where we said, our goal is some developer sitting on a couch who's never used the API before, American Idol running in the background, should be able to open up his laptop, see documentation, and have something working in 20, 30 minutes. That was the goal we were shooting for. We wanted something which was open. We wanted to build on existing, well-understood industry norms and technologies. We did not want to reinvent the wheel. And we wanted it to be simple and usable so that the stuff that you want to do every day is kind of easy. So that's kind of the meta view on what we kind of wanted to do. Now, let's go dig into the details, and let's see exactly how the API looks like. I'm a bottoms-up kind of guy. I like to understand technology by looking at the lowest layers and working my way up. So I'm going to explain this API to you in the exact same way. So what exists at the foundation of this API at the lowest protocol level? Well, at the lowest protocol level, the API is all REST and XML. Now, if you're a developer and you have seen a REST API from Windows Azure or from any of the Azure services, this API will look super familiar to you. It's just an API which adheres to good RESTful principles. It's XML. We believe it's clean XML. It's all stuff that you guys are used to and you've been working with for quite some time. Now, so that's as far as how the messages and the URIs look like. But how do we actually communicate back and forth? So the channel that the REST and XML goes over is, oops. This range is quite limited. The channel that this goes over is HTTPS. So every request that you make using this API goes over HTTPS. So this makes sure that no one can see what you're doing, and no one can modify the contents of your request on the fly. So here's a sample request from this API. This is a request for creating a new deployment. Now, the actual details aren't important, because what I want to really show you is the shape and the feel of it. So as you can see, the API lives off https management.core.windows.net. The stuff in red is the things that you fill in. Like subscription ID is a unique ID that you find in the portal, which uniquely identifies you. Service name is the service name that you want to upload this deployment to. Slot name is whether you want to get it into staging and production. So you kind of see how things that you're familiar with in the portal show up in a similar fashion in the API. This request, it's actually the most complex request in the API. That's why I wanted to show it on the slide. This is the XML payload that you send with the API. And this basically specifies what you want the deployment to be called, where the package for the deployment is, and what the configuration is. If you look at this closely, you will notice that this is the exact same data that the portal asks you for, except that it's asking you a bunch of text boxes, and you kind of click next, next, next. But in this, we kind of package it all up in HTTP and XML. All right. So that's the protocol. On top of that, we built an authentication and authorization layer. So how does that work? Well, that works using X509 certs. How many people here have experience with certificates in any shape or form? OK, so quite a few, right? So for everyone else, all that you need to know is that this is nothing unfamiliar. If you've ever visited an SSL-based website, which is everybody, you have seen X509 certs in action, because that's the thing which powers the little lock icon. For the purpose of this talk, all you need to know is that the X509 cert is just a nice, handy way to package up a public and private key pair. And the public key, you hand it over to us. You keep the private key on your machines. And when you make an API request, you stick the key on it, and we'll check it and make sure that it belongs to you. And boom. So that's how we authenticate, we do auth using this API. Now, when I talk about X509 certs, people always have a bunch of questions, right? They're like, what kind of certificates do you support? And what about revocation? And what certs can I use? Can I generate it on my own machine? So what's the deal? I'm happy to announce that we support any valid X509 cert. So you can generate this on your very own machine. You can go open up your laptop right now. You can go into IIS Service Manager, or you can open up make.cert.exe, and you can generate a cert right now. If you have a certificate from a certificate authority like VeriSign, you can use that as well. So you can use any valid certificate. Next, the next thing we allow you to do is to go upload multiple certificates into your account. What does it mean? Instead of having just one certificate or like one password, you can generate a ton of them, and you can use one of them for your build machine, one of them for your development machine. You can hand out one to your annoying neighbor in the next cubicle. You can generate a bunch of certs and authorize each of those certs. And all those certs will, you're essentially delegating responsibility to all those certs as well. So the cool thing here is you can revoke those certs at any point in time. So let's say we generated a cert, and you plugged it into a tool built by a third-party company. After some point in time, your relationship with the company is over, and you want to make sure they can't access your services anymore. All you have to do is to go into the portal and say, OK, I want to revoke that cert. Boom, that's it. They won't be able to access the API anymore. OK, so that's the protocol layer, and that's authentication. On top of that comes the most important piece, which is the actual operations supported by the API. So what can the API actually do? So most of you will spend most of your time on this particular bullet, which is the ability to create new deployments, delete deployments, see what the deployment status is, and go update information about the deployment. This is the API's bread and butter. This is the kind of thing that you'll have your build scripts doing. This is what you'll probably be doing every single day. Next, You can use the API to look at your role status. You can see what each of your role instances are doing. Are they doing well? Have they gone down? Are they still initializing? So you can get all the information that the portal was showing you. You get that in the API as well. After that, you can change the configuration for your deployment. So what this means is, during the first day keynote, you saw Matt Mullenweg of WordPress come out on stage, and you saw him type in this XML in this text box to add, remove instances, right? So you can do the exact same thing using the API. So you can go add, remove VMs on demand. You can change any configuration you want, exactly the same as what the portal supports. Right. The next functionality offered by the API is the ability to go upgrade your service. So this is essentially going and swapping, staging, and production, as well as going and doing a fancy new upgrade mechanism we have that I'll kind of talk about later on in this talk. And finally, you can go look at your storage keys. You can go see what your storage keys are. You can go regenerate them at any point in time. You can do key rotations. You can do a lot of cool things by looking at the storage keys. So this is the core important functionality supported by the API. There's a ton of other ancillary stuff like looking at affinity groups, looking at your hosted services, which I'm not really going to get into. You can check out the documentation. But this is really the core work that you'll be doing using the API. One interesting question is, what can the portal do that the API cannot? And currently, there are two such things. First is, the portal gives you access to billing data. And the API currently does not do that. And the second is that the portal lets you create these new hosted service applications, your foo.cloudapp.net and your foo.blob.co.windows.net. Currently, the API will not let you do that. Once you have created them in the portal, you can do anything you want with them using the API, but you just can't create them. Now, having said that, you have to remember that this is a V1 release of this API, so we will obviously be adding more stuff as time goes on. So that's the protocol, that's auth, and those are the operations supported by this API. So how can you actually write code against it? How do you actually go use it? The first and simplest way to go use this API is through the tool we call csmanage.exe. This is a free sample download. It's up on MSDN Code Gallery. And this essentially is a nice, nifty command line tool which supports every single operation that the API supports. So this is a great way to kind of explore the API, see what you can do, and essentially use it as a replacement for the development portal if you so choose. If you're a .NET developer, you can use the client library that csmanage itself is built on top of. Again, this library has source. It's a sample upon Code Gallery. So you can then use this client library to go absolutely build anything you want. If you're not a .NET developer, no problem. You can go use the REST and XML specification to go construct your own client library, or go grab one that the community has already built out. Now, here's the secret. I don't expect a lot of you to actually write code against this API. I expect you to use tools that have actually written code against this API for you. And the biggest consumer is going to be Visual Studio. So you will see a lot of integration between Visual Studio and this API in the future. And apart from Visual Studio, there are a ton of other tools from the community and partners that are adding support on top of this API. So if you're a tool developer, this is great because you now can do all these fancy integration with the Windows Azure platform. All right. That's enough talk. Let's go do some demos. Now, I do have a couple of things to note about my demos. Each and every single demo I have goes and hits the cloud. Right? It's not the developer fabric stuff running on my local machine. Every single one goes and hits the live internet. Okay? And to go add pressure, I have a bunch of my own teammates sitting out here. So it's like, I feel a lot of pressure when doing this demo. So even if the demo doesn't work, I want you guys to all go crazy. Imagine I'm Oprah and I'm just giving away free stuff. Okay, so or Sinofsky giving away a laptop. Just go crazy. All right. So I'm using Firefox here because I saw a tweet yesterday asking whether the Windows Azure Development Portal actually supports Firefox. OK, my internet connection is weird. Someone has actually plugged out my Ethernet cable. How thoughtful of them. Darn you. How was the party yesterday? I am getting bits. All right. So before I came here, I spent some time setting up my account. So you can see I have a developer portal account over here, and I have a hosted service running. If I go into that, you will see a very basic Hello World application. Did I actually click that? You will see a very basic Hello World application running with one role instance, right? It's nothing fancy, just plain vanilla stuff. Now, I spoke about how you needed X509 certs to go work with this API. So what I've actually done is I've gone and generated one. So the easiest way to go generate a cert is using this IIS manager. And you just go here, you go click on Create Self-Signed Cert, and it's going to go generate one for you. So that's the easiest way to do it. I've already done that. So if I go look into my certificate manager, I see this pre-configured cert show up. This is a self-signed cert that I just generated within a second. And this essentially means that the Windows certificate store has the private key for that certificate. All right, so I now have a certificate. The next thing I need to do is to go tell the Windows Azure developer portal that to trust this certificate for my account. So to do that, I just needed to go here, and I needed to go export this certificate. I've already done that. And I've exported it into this preconfig.cer. The CER file means that it only contains the public key portion of this certificate, not the private key part. And I've also gone into the developer portal, and I've uploaded that certificate using this API certificates functionality. So if you go here, if you go into Manage My API Certificates, you see the same pre-configured cert which shows up in my cert store. So now Windows Azure knows to trust this certificate for any request I make. All right. Now, my next goal is to go write the simplest piece of code I can to go generate a valid request against this API. So to do that, I'm going to go into Visual Studio. And this is a plain vanilla console application out of the box. Just .NET 3.5 and nothing else. I've brought in some namespaces. And what I need to do now is to go generate the right HTTP request. So let me go do that. So I'm going to say webRequest.create. Now, I need to know the actual URL to make the request on. I do know that all the API operations live off management.core.windows.net. I know that. The next thing I need is the subscription ID, this unique identifier which identifies me to this API. So that is the piece of text that you see at the bottom. I've actually gone and copied that into a comment. How did that show up? Let me go add that here. All right. So now I have a HTTP web request against management.core.windows.net with my subscription ID. What I want to do is to go list out the hosted services under that account. All right. So I now have a HTTP request. And this does a GET request by default, so it's just pulling in information. Now, API has a versioning mechanism built in. So I'm going to say that I want to access the October version of this API. So I'm going to say x-ms-version 2009-1001. OK, so I have a request, and I have the header added. The next thing I need to do is to go add that X509 certificate. So the way to do that is I go here. I new up a new X509 certificate object. I say create from certificate file. I point it to that preconfig.cer. And that's it. OK, so here's the deal. If I met one of you in a dark alley and you beat me up and you stole this CER file away from me, not that any of you would do that, this code will not work on your machine. The reason is that CR file only works because it has a matching certificate in the cert store. So if you want to beat me up, you need to grab that cert store export as well. But don't do that. I'm nice. OK, so we now have a certificate. All I want to do is to get back the response from the we now have a request, and I want to get back the response from the request. So I'm going to say get response and get response stream. It gives me back some XML. So I'm going to read that XML into a string. And finally, I'm going to just write it out to the console. Let's put a console.read there to make sure it blocks. OK, and let's go run this guy. Oops. Did I miss? OK. All right. So new request to write URL, which is basically management.co.windows.net services hosted services. We add the versioning header. We add a client certificate. Now, on this line, we spend some time actually going out over the internet and getting a response. Come on now. Any moment now. And what it's going to do after getting that response, yay, in PDC network, I love you. So OK, there we go. And boom, right? So you've now actually seen an actual API request go out over the wire and get back my list of hosted services. Isn't it great when you have your own team members in the audience to spark off applause? Thank you, Matt. OK, so if you see over here, you see the exact same list of hosted services that you saw in the developer portal. All right. The demos are going to be a bit challenging with this network. OK, here's the deal. None of you will ever need to write this code, because we have built a ton of tools and libraries to actually go write this code for you. So let me show you one of them right now. This is CS Manage. And I have actually configured it already to go use the right certificate and subscriptions. If you go here, you see I've set up a config file with the certificate, subscription, and the certificate. So I just need, let's say I want to get back the same list of hosted services. I go CS Manage, list hosted services. Go, you little tool, you. Yay. So thank you, Matt, for the completely unprompted applause. OK, so you get back the exact same thing. So the deal is you can do much more interesting things. Any operation the API supports, you can do in this using this tool. So let's say I want to dig in to the Sriram K test hosted service. I'm going to say, show me deployments. OK, so this is going to go out. And this is what this has done is not only has it got back the list of that properties of hosted service, it's also showing me the roles in the hosted service and what status they are in. So you can kind of see how we can use this API to figure out what the status of your roles are. All right, so to actually create a new deployment, I first thought of using CS Manage, but then I changed my mind. Yesterday in the speaker room, I came up with something nifty. So here's the deal. How many of you use MS Build as part of Team Foundation Server or somewhere in your workflow? OK, so wouldn't it be nice if after you built a package using Visual Studio, a cloud package, if you would automatically go and upload it to the cloud for you? So that's what I spent 20 minutes in the speaker room, and I came up with this MS Build task. Now, by the way, I am not an MS Build person, so this came off like 10 minutes of MSDN. And basically, this descends from the core task object from MS Build. And it's going to actually upload the deployment to the cloud. We'll step through the code in a minute. what I want to draw your attention to here is the reference on the right, which is Microsoft.samples or Windows Azure Service Management. This refers the same client library which CS Manage uses. So this is a sample client library source out there so that you can use and do exactly what I did, but write better code. OK. Everything in MS Build needs a project. So here's the project file I'm going to use. First, there's a using task to actually bring in that assembly which I just built. I shell out to the MS Build task over here to go use visuals to go build the cloud service package for me, which is this last publish target. And I finally use my Azure task, and I set up the subscription ID, the certificate thumbprint, the storage account, and storage creds. OK. So let me go build that. So there is an MS Build project in this folder, this MS Build test.proj. If I go build, first it's going to go generate the package for me. And once it has done that, in my MS Build task, I put a line of code to go launch the debugger. So what you're going to see is after the package has been published, it's going to go pop up a window to launch the debugger. Here we go. I'm going to say, yes, I want Azure task. All right. So first, what we need to do is we need to go upload the package to blob storage. The way this works is the API only supports packages which are there in blob storage accounts under the same subscription. So this makes sure that everything is nice and secure, and we store the packages reliably. So you can't do what you do using the portal today, which is to upload it from the local file system directly. You need to kind of go through blob storage. So that's around like a megabyte. Actually, that's like quite a few megabytes that we're uploading, which is probably going to take some time. After we are done doing the uploading, this is going to go create the WCF channel to the API. It's going to create this data structure to talk about what the deployment needs to be, what the package URL is, what the configuration is, what the label is, and so on. And after that, it's going to actually go make the request. OK, so there's like several megabytes, so this is going to take some time. I'm going to give it around a second, or I'll move on. But you basically kind of get the idea of how you can use the client library and integrate this into any workflow that you have currently. All right. OK, so I'm going to give up on this, and we'll probably come back to it later. So this is actually uploading like several megabytes of packages to blob storage. But you kind of get the idea of what it's actually going to do. OK, so let me get back to my talk. So you kind of got a feel for what the service management API can do and how you can use it to go integrate into your workflow and generally kind of build tools and utilities on top of it. One piece of functionality which I did not show was PowerShell integration. There is a PowerShell sample out there which uses service management API, which is really cool as well. And you should definitely go check that out. OK, so you saw what all the service management API can do. So what's it going to cost? So I just want to spend the next few minutes going into a detailed discussion on how pricing for the service management API is going to work. OK? Here's the discussion. There is no pricing for the service management API. It's free. The deal, you can make any, yes, you can upload. Thank you. It's always nice to send less dollars to Steve Ballmer. The deal is you can make any number of requests you want. The only thing you need to watch out for is we reserve the right to throttle you if we think you're doing something malicious. But for most normal usage, this is never going to be an issue at all unless you're really being naughty and you're really trying to do something bad. So it's absolutely free. Go play with it. You're not going to see any bill. Just go party. OK, so now that you know what the API can do, I want to spend a few minutes talking about what you can actually build on top of this API. You see, any API is like a set of Lego blocks. You can build something small and interesting like this Christmas tree, or you can build something large and huge like this real life-size Lego house, which costs like $3.5 million. So it's really up to you. So what can you do using this API? Here are some ideas or suggestions. The first is you can go integrate with tools and dashboards. So you saw how you can integrate with PowerShell. You should have seen how it should integrate with MS Build if it actually finished pumping packets over the network. So you can kind of integrate with any tool that you want. Next, yeah, again, MS Build, integrate into your workflow. The next interesting piece of functionality that the API can do is to go integrate into monitoring systems. So you can use the API. You can use the API's ability to look into your service, tell you what your service is doing to perform some very interesting things. And that's actually what the third part of my talk is going to be about. So we'll dig into this in detail. So I want to talk about one partner who has taken the time to go put these Lego blocks together in an interesting way. Persistent Systems has gone and built an e-governance app which runs on Windows Azure. And what they have done is they took the service management API. We gave them a phone call. We said, hey, we have this API coming out. Do you guys want to do something with it? So they took the service management API, and they added the ability to go provision new customers directly, as well as scale up and scale down their tenant based on load. So it's fairly, it's as somebody who's kind of worked on this API, it's super interesting to see real-world usage and somebody actually real people doing filing requests for problems with roads or doing all this other governmenty stuff and doing real things with the API. So that's kind of cool. All right, so that is the end of part 1 of my talk. Okay, deep cleansing breath. Inhale, inhale. Exhale. OK. For part 2, I want to go back to December 1996. NASA launched one of its biggest missions to date. It was the Pathfinder mission, and it was a mission to Mars. So the idea was that this little robot went to the Martian landscape, and it started taking pictures on the Martian landscape. So everything was handy-dandy for a few days, until after some time, it stopped working. Yeah, it actually said, oh, in a blue little balloon. So the developers back in Houston were stumped. These are actual photos taken from NASA's website. So, and after quite a bit of debugging, they narrowed it down to a priority inversion problem. It turns out that all bugs are the same. I mean, that has to be like the best bit of remote debugging that anybody has ever done when you go across planets. Yeah, I can't debug from here to the cloud. Well, think about that. So once they did that, they then went and did something even more interesting, which is to go write another piece of program which patches the operating system in memory. And then they did this. Pushed out what has to be the hardest patch in history from Earth to Mars. And guess what? Everything worked fine, and they were all super happy. So forget the talk and forget the context here. Isn't this really cool? I mean, you can't get cooler than this in terms of how you go remote debug or how you actually go push out updates. So the reason I kind of told this story is because upgrades can be very hard. So in Windows Azure, we really tried to give you a bunch of powerful options on how you can upgrade your service so that you can look like the NASA engineers from the second half rather than the first. So with Windows Azure, there are 3 primary ways you can upgrade your service. And I'm going to do this Letterman style. Okay? So I'm going to go from the one that you're probably going to use the least to the one that you're probably going to use the most. So at number 3, you have something we call stop and start. Here's how it works. If you have huge updates to your service, like you completely change your service architecture, you want to reset your storage, change schemas, you have these huge changes, what you can do is to go take down your service for a short period of time, upload your package, and then restart your service. Now, as you can imagine, this involves downtime, so you really don't want to do this unless it's a last resort option, but it is an option. What most of you are probably used to is option number 2, which is whip swap. Now, if any of you have developed with Windows Azure and actually deployed an application, you have seen this in action. What happens is you go upload a package to your staging service, staging deployment. When you think it's good to go, you do a whip swap and swap it with production. And find your staging version runs at production, and your production version runs in staging, and you have your final build running at the domain it should be. So this is great, and this is still going to be supported and still a great, great option. But we really, really want you to look at number 1, which is this new functionality we have just released called in-place upgrade. Here's how this works. So let's forget the staging deployment for now, okay? The staging slot is still there. You can use it if you want, but you don't need to. So you have your production deployment. And when you have a new build, you go upload the package to it. So the package goes onto your new build. And here's the deal. After a few minutes, it finishes upgrading, and your new build will actually be running at your production deployment. Okay? So no staging deployment, none of that. It's quite easy and quite simple to actually do this. Now, if you have a simple service up and running in the cloud, this is all you need to know. I go there, I press a button, I point it to my package, it goes up there, boom, I'm done. This is all you need to know. But if you want precise control, we have given you a bunch of knobs that you can turn to kind of control how exactly this upgrade is going to roll out. And all that functionality is based on a concept called an upgrade domain. What is an upgrade domain? Here's the deal. Your service is split automatically by the Windows Azure Fabric into a number of upgrade domains. And when we send out a new upgrade, we walk upgrade domain by upgrade domain, taking down VMs in one before moving on to the other. Now, this is nothing new. For all of us that have deployed a service already, this is exactly what we do when we upgrade one, right? We go upgrade those set of machines first, then we move on to the next. So this is exactly the same thing. So how does this work? So you remember this picture I showed you of this production deployment? That picture is a lie, because in reality, it's a bunch of web and worker role VMs actually running, that one deployment acts as a facade for all these virtual machines. Now, let us say you want to say, I want 2 upgrade domains. And like that attribute at the top shows, this is something that you can specify in the service definition file in Visual Studio. Let's say I say, I want 2 upgrade domains. What's going to happen? Well, we're going to split, in this case, we have 6 web and 6 worker roles. So we're going to split the first 3 web instances and first 3 worker role instances into upgrade domain 0. We're going to split the rest into upgrade domain 1. OK. Now, what happens when an update comes out? So in this case, you have 2 options. One is you can say, just go upgrade all of them. Take down upgrade domain 0, update the bits on all those VMs. When you're done with that, move on to upgrade domain 2, and so on and so forth. The other one, if you want even more precise control, is something we call manual upgrade. How does that work? Let us say you're finished upgrading upgrade domain 0. At this point in time, the fabric is just going to stop. It's going to stop, and it's going to wait for you to go check whether your service is up and running. So this is your chance to go say, hey, you know what? That upgrade domain 0's upgrade went very well. It's all fine. Everything looks good. OK, I'm going to press the button to move on to upgrade domain 2, and so on and so forth. So this gives you precise control and lets you set the pace for how and when you roll out your upgrades. Here's a little secret. This is exactly how we upgrade our own internal services. So if you go look at any of the storage talks, this is exactly what they are doing underneath the covers as well. So you can specify any number of upgrade domains. Let's say you picked 3. We're going to split them into 2 web and worker role instances each. So you can imagine how, depending on the number of upgrade domains, we just kind of pack them into as even a number as we can. Here's an option that I don't want you to do. Please don't try this at home. OK, it's going to finish upgrading all 3 domains. What I don't want you to do is to set 1 upgrade domain. Why is that? Because when you have only 1 upgrade domain, all your web and worker role instances are going to fall into the same upgrade domain. And when that happens, when you push out a new upgrade, we're going to take down all those instances down, and we're going to update bits in them. So you will see downtime. So don't do this at home. This is only for demo purposes in a closed course by professional stunt drivers. OK. Now, let's go back to this picture. Let us say you found a typo in your web role. Okay? You said, OK, I made a spelling mistake. But your worker role is running some long transaction. Your worker role is calculating 10 million digits of pi, and it's on digit 5 million. Or your worker role is called deep thought, and is calculating the answer to life, universe, and everything. You don't want to go take down the worker role just because you updated bits on the web role, right? Just because you had a typo. So one of the options that we are providing you with this new feature is the ability to pick which role you want to upgrade. So let's say you want to update the web role only. We'll again do this deployment, but we will not touch the other roles. So we're going to update web role, web role, web role only. And your worker role is going to keep running just as it is. So you can kind of see how we kind of given you knobs to to really control how you roll out your upgrades. Now, when I kind of spoke about swap and I moved on to in-place upgrade, I kind of didn't really talk about when to use either, right? What is kind of bad about swap, or when to use either? Is swap really bad? So the answer is there are a few cases when you really want to look at using in-place upgrade. The first one, like I just said, is when you have changes affecting a single role, because in-place upgrade can make sure that we touch only that role when we roll out the upgrade. And this makes things much, much faster because the Windows Azure Fabric has much less work to do. Next is when you have something we call soft state. Let us say you're running MySQL, or let us say you're running memcached. You have a lot of state. You have a state in memory. You might have state on disk. If you take your machines down, it's going to take some time to kind of build up that state again, kind of page in all that workload, right? So if you have soft state, you really want to go look at in-place upgrade, because this can make your life a lot easier, and your app won't see perf issues. And next, and probably the most important, you don't have to maintain a staging environment. Now, I have 2 services with 2 VMs each. And heck, I work for the team, so I don't have to pay anything for it, right? But let us say you have a huge service with hundreds of VMs, and you want to do swap. In that case, you have to run a staging deployment, which has hundreds of VMs, and a production deployment, which has hundreds of VMs. So you're paying for a lot of VMs, VMRs that you probably don't need to. So with in-place upgrade, you don't need to do that. Your staging deployment can just be a couple of VMs where you do some testing, and then you use in-place upgrade to go roll out to production. OK, so let's go actually see a demo of how this works. Let me get into Internet Explorer. Thank you, network connectivity. So while that comes up, I want to show you this package. So I have a web and worker role package here, and I've actually gone and specified that I want 3 upgrade domains in it. Now, what I'm going to do is I'm going to go, I want to make a small change to my web role alone. So I'm going to say, OK, Sinofsky, a tablet is good, but what about a Ferrari next time? The Windows guys have a ton of money. I'm going to get into so much trouble for saying that. OK, so I just have updated something to my web role alone, and I'm going to go generate a new package with my new web role bits. Has this come up? Yay, it has. All right, I have the previous version of this service already running in the cloud. So you see here, it's the exact same web and worker role, and it's a previous version. I want to upgrade only the web role alone. I can do this using the API, but I want to kind of show you how to do this using the portal. So I'm going to go here. Let's copy the path to this new package. You see this new upgrade button? Let me zoom in. There's a new upgrade button that shows up in the portal. I want to click that. Go, 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 go. So what's going to come up is a bunch of options on how you actually want to roll out in-place upgrade. At the top, you see what I just spoke about, automatic versus manual. I'm going to leave it automatic because you're kind of running short on time. This means that all the upgrade domains will kind of be walked one after the other by the Windows Azure Fabric. I'm going to point it to the package. I'm going to point it to my configuration. I'm going to say, pick some label. And finally, at the bottom, I have this nice little drop-down menu which lists out the actual roles in my service. So if you go see here, it lists out all the roles in my service, and I'm going to say I want to upgrade only my web role. Boom, click deploy. And so what's going to happen is it's going to go upload the package, probably taking some time over this network. It's going to upload the package over the network, and it's going to go upgrade domain 0, 1, and 2, but it's only going to touch the web roles. The worker roles will not be touched at all. OK. I love demos when you can do everything on your local machine. Aren't they so cool when you don't have to depend on packets flying over the network? But you kind of get the idea of how you can use in-place upgrade to kind of precisely control how you want to do this. So while that's happening, I kind of want to see this move on a bit. I want to show you how you can do the same using the PowerShell tools. So here's a little PowerShell script. And this basically lets you script this functionality. And you can basically say, OK, I want to upgrade this particular role. You set a variable. And it will actually go upgrade that role in place. And it will actually wait for upgrade to finish. So again, you kind of see how you can use all these tools. Boom, there we go. You can see how we use all these tools to go use the API. So here, you see it upgrading my first upgrade domain. And when it's done with that, it's going to go move on upgrade domain by upgrade domain. OK? So that's in-place upgrade. And that brings me to the end of part 2. Now, thank you. And Matt wasn't even involved in that. OK. Few weeks ago, when this talk was originally planned, this talk was supposed to end right there. Okay, I was supposed to go show in-place upgrade, and that was it. That's all we were covering. But then I get a phone call from some technical evangelists in Microsoft, and they said, hey, we have this crazy idea for something we want to build, and can you show it? So in the last just a week or so, we have put together something. This is not a feature of the platform itself. Rather, it uses a lot of the API and the building blocks I've shown you, and kind of you put them together. And kind of seeing my luck with the demo so far, it's probably not going to work. OK? But do you guys want me to show it anyway? Yeah. All right. So this time, we start with this gentleman over here. This is James Maxwell. He is a Scottish physicist from the 19th century. And he is best known for his association with this weird-looking device. This is a centrifugal governor. This was the very first device which could regulate engine output by regulating the fuel that was sent to it. So it could say, OK, I want the engine to remain at this speed. So it kind of change the amount of fuel pumped in to make sure the engine remains at the speed. Kind of seems basic now, but it's kind of a big deal back then. Because that led to the beginning of modern control system theory. You have a process which does something. You have a feedback loop. And then you have a controlling process which takes action based on that feedback. This is nothing fancy. We are all used to this. This is the exact same principle you see applied in everyday objects like a thermostat, which looks at the heat in your room and kind of figures out how much air to pump in or what temperature to pump in. And that is essentially the theme of the part 3 of my talk. Where we are going to go build an auto-scaling solution using the same kind of control loop mechanism. Now, what is auto-scaling? For my demo, I'm going to say auto-scaling is the ability to go scale up or scale down your service based on some KPIs, some key performance indicators. It could be service latency. It could be transactions processed per minute. It could be anything you want. So that's what we want to do. How does this fit in with the control systems metaphor? Well, you have a process, in this case, the application, right? This is your web and worker role doing stuff. You have a feedback loop. Now, this can be anything you want. Now, yesterday, Matt Kerner over here did this great talk on the new logging diagnostics API we are shipping. So you can make the app pump out all this health information on how it's doing, perf counters, logs. So you're kind of getting all this data on what exactly your app is doing and how it's behaving at any point in time. If you don't want to use that, you can use anything else you want. You can just ping the app and see what the latency is, any sort of feedback loop. This feedback loop goes into a control system process. This can be another service. This can run in the cloud. This can run underneath your table. This can run anything, anywhere you want. What this is going to do is going to take a look at all the feedback coming through the diagnostic API and figure out what should I do about this. Is it time to do something? Should I add a VM? Should I remove a VM? Should I do something else? And when it decides what to do, it's going to do that using the service management API we just showed you. So you kind of see how we're going to use all these building block pieces to put together auto-scaling. Let me jump into a demo. So I have a basic web app running in my developer portal. go. So it essentially just has one web and one worker role. The interesting thing is it exposes a WCF service, and basically it also processes messages of a queue. So it listens to a Windows Azure storage queue, and when it sees some message, it picks it up, and it just basically waits for some time on it. So it just essentially simulates work on a queue. Now, the next thing I want to do is I want to go run this health monitoring app. So this is just a simple little dashboard that we put together in a very short period of time. And what this does is that it goes and polls the queue to kind of see what kind of workload the application is facing. So this is kind of a way to kind of get information on the health of your service. In this particular case, we are looking at the queue. But you can imagine, instead of the queue, looking at something else, like looking at, what are my perf counters like? What's my CPU usage like? Anything you want. OK, so the app has no load now, so you kind of see nothing over here. And the final and the most important piece is this, something we call a scaling engine. This is the controlling process. What this guy does is basically goes and polls the queue every few seconds to kind of get a sense for what kind of work, what kind of stress is the application under. Now, this is like one example, right? In a real-world application, this will be looking at latency. This will be looking at perf counters. This will be looking at a bunch of other factors. But for the purpose of this is just going to look at queue length. Now, next thing to do is to actually put some load on the application. So to go do that, I'm going to launch a new instance of a load client. And I'm going to say, generate 60 messages per minute. So it's about a message a second. So what this is going to do is it's going to go dump messages into the queue at the rate I just specified. So if I go back here, you kind of see the load pick up as messages kind of flow into the queue. And if you go back into the control system application, you kind of see that this is kind of picking up this value, but it's not doing anything about it. The reason it's not doing anything about it is because of this red line. That red line is the threshold I've specified as saying, above this red line, I want you to add a new VM, because that means I have too much load and the app can't deal with it. OK? So you kind of see this thing go up slowly. I'm going to increase the pace by bumping it really high. Let's go. This monitoring dashboard UI kind of has a lag in refreshing. But this scaling app goes and refreshes like every 8 seconds. So this is, you have the load client generating a bunch of new messages into the queue, and you have our scaling engine looking at the queue and trying to figure out what it should do about it. All right. Huh? No, I don't think I should do that. Oh, there we go. OK, I think the right click actually messed things up. Yeah. Oh, OK. So what it actually did when I was actually kind of scrolling through the output was it actually went and kicked off the new request. You can't see that here, but the pending action means that it went and generated right here. This guy, this means that this went and generated a new request into the service management API, and it's essentially going and adding a new VM to my service. So if I go back here and refresh this, so what's going to happen is over the next few minutes, it's going to actually go add a new VM. And you should hopefully see, yeah, so here the plus sign, that means that it went and actually tried to add a new VM. It was kind of not very clear with the console output. And over the next few minutes, you'll kind of see Windows Azure Fabric going and kicking off a new VM and hopefully bringing down the load because the new VM is running. OK. So you can kind of see this is all pretty rough right now, and it's all like duct wire and taped together. But the cool thing is we are going to go polish this up, and we're going to put out this code as a sample, and this is going to be put out on Code Gallery. So you can kind of use it in your own application and go modify it, do anything you want, and kind of see how to go build auto scaling into your application. Now, as you can obviously see it from the demo, number one, I don't know how to deal with really huge command windows. But also, you can also see that auto-scaling is a hard problem. You have to worry about backing off. You have to worry about if there's already an action happening, I need to back off because I don't want to go keep piling on changes. You need to worry about the right amount of thresholds. There are all these different aspects to worry about auto-scaling. It's really a non-trivial problem. So this is one place where we really expect the community to kick in. We really expect our community to go build interesting solutions using the service management API and using all the other pieces that we kind of shown you over the last few days. Apart from the community, we really expect our partner ecosystem to kick in as well. Now, there is one particular partner I really want to talk about. When we were designing the service management API, there was this one particular company which I was a huge fan of. I'm a huge fan of their work in service management and auto scaling. And I was like, wouldn't it be cool if they could actually use this API to do some auto scaling? So we've kind of been talking with them for some time. And so I'm really happy to announce that RightScale is announcing that they will be supporting Windows Azure. So instead of my quirky little demo over here, you will see some real professional auto-scaling solutions on the platform. But RightScale just one. You probably expect to see a ton of other partners kind of build on top of the service management API and all these other pieces. And that brings me to the end of part 3 and to the end of my talk. Before you guys come up for questions, I want to say 3 things. Number one, I want to say that please go try out these things. Go try out the API. Go play with the SDK. We really thrive on feedback. So tell us what works and what doesn't. So really go play with these things. Number 2, please go fill out your session evals. There's $1 donated for every eval that's filled out to the Boys and Girls Club of LA. So please go do that. And finally, I just want to say that you guys have been an amazing audience to work with. I kind of like to goof off on stage and probably not have working demos. And it wouldn't have been as much fun if you guys went into it. So you guys have just been great. So thank you very much. So I think we're out of time. I don't want to mess up the next speaker. So what I'll do is I'll just hang out outside, or you can find me in the Windows Azure Lounge, or you can just drop me an email if you have any questions. So thank you all for coming. Thank you.